Great. So on the notion of what was said previously, that this kind of has to be better than a blog post, I want to today talk a little bit about the things that people wouldn't probably typically blog about, some of the challenges we have in AI and machine learning as a field, but also some of the potential solutions we discover today, and obviously touch on all the opportunities that we get. 20, 50 years ago, people said Go is the most complex thing we can do as humanity. It's the most complex game that is out there. Just the possibilities you have of arranging, these small black and white dots on the 64 by 64 grid is basically more than there's atoms in the entire visible universe today. So people said it's impossible for humans to lose against computers because you need intuition, you need all these things that only humans have. And then what happened only two years ago, as many pointed out, this guy to that date was considered the best player in Go of the world. I think some people even say in history he kind of beat every other human being like 5-0, and then he loses against the computer 50 years before everyone predicted that would happen. So that's kind of a huge milestone for the field of AI and machine learning, went all crazy, and then something even cooler happened. That's what less people talk about because it includes some math and some graphs and stuff like that, and it's not as cool of a story. But what happened here is the green line is the performance, and I'm not going to get into details of how it's measured and stuff like that, but it's the performance of AlphaGo beating the best human in it. And then just 40 days later, they came up with, okay, we have this new algorithm that instead of learning from human play, it only plays against itself and kind of teaches itself how to play Go, and just crazy exceeds the performance of the previously best system playing Go. And now, that's even later, and there's no graph about that, now it can do that with 10 times less computation power than it did before. So it's like massive milestone after massive milestone. You see the field booming, and just 2-3 days ago, this happened.
See, how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when? Today?
Next Wednesday at 6 p.m.
Oh, actually we reserve for like after like 5 people. For 4 people you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Bye bye.
So this recording is back from Google I/O just last week. And why is this crazy? Huh? So obviously, any of you who's ever tried to reserve a restaurant in San Francisco knows that it's very hard for humans to make that reservation because most of the people speak English that's not quite like the English we typically speak. So it's hard for us to recognize what they're telling us. Second thing that's cool about this video is the voice of this kind of symbol obviously is Google's new duplex system that now can do kinds of, the new assistant can do all kinds of interesting things for you. But if you noticed, it has some tiny little nuances that only humans use in their language, like, okay, gotcha. Thank you. These kinds of nuances that we haven't at all seen from computers before. And now this is kind of a very human approach to making a phone call for a restaurant reservation. Now, obviously, restaurant reservations are not like the killer use case, but we can easily imagine therapeutical applications of this kind of technology. We can imagine elderly care, we can imagine kindergarten, whatever kind of agents that we need, but they might be like not as well paid as most of our occupations that could be potentially automated or helped by computers. That was not at all possible 5 years ago. And if you talk to any journalist, or even me, I have to admit, a year back I would have said, it's 5 years out there. And now it's happened last week. So that's kind of exciting. But most people, when they talk about AI and machine learning, they kind of struggle to understand and clearly define what it is. So I want to just take 5 minutes to make sure we're all on the same page in this room and we all know what we're talking about when we talk about AI and machine learning. So there's this beautiful, and sorry for the slide fuck up, there's this beautiful definition from Herbert Simon, and he says, human beings viewed as behaving systems are quite simple. The apparent complexity of our behavior over time is largely due to the reflection of the complexity of the environment in which we live in, and that we adapt to make that behavior. And then the second definition I want to throw at you is machine learning and AI is a computer field of as a subfield of computer science that deals with the construction and study of systems that can learn from data, so observations, rather than only explicitly programmed instructions. So 20 years ago, when you had a computer program, almost everything was rule-based. And they said, okay, if this thing happened, then that's the reaction you have to take, and if this thing happens, then that's the other reaction you have to take. It's like a decision tree. Today, most of these AI machine learning systems, and there's some exceptions, but most of them, basically no programmer ever sat there saying, but this has to happen, and then this has to happen. They all leverage this first definition that we looked at of human behavior that comes from the complexity of the environments which we live in, and basically say, we throw all these very complex observations, meaning data, on our computers, our computing systems, and then they will come up with the rules just by observing from that data and be able to make those decisions. The honest definition of that process, and this is an KCG cartoon, basically says how the real process of building an AI machine learning system today most of the times work. And so they say, okay, yeah, this is your machine learning system. Yep, you just pour a lot of data into this big pile of linear algebra, then collect the answers on the other side. And if the answers are wrong, I just stir the whole pile until I get answers that make sense. And that's honestly the kind of stuff I spend most of my time during the day with. It's just like stirring piles until the answers look right. But still then, AI and machine learning is not only one single thing. It's a toolbox that consists of many different tools that we've developed as a field of study, developed over many years. So some of the things you obviously know is recommendation engines. That's like the typical Amazon, people who bought this usually also buy this. Then there's NLP text mining. That's what we've previously seen with Google Voice Assistants. Then there's what people talk, and natural language generation, obviously. People talk about predictive analytics, so taking some sort of time series and being able to say, usually when the weather is good and it's rainy, then this is the kind of yield in an agricultural field that I'm able to expect that season. And then one of the exciting things that just takes off recently is this thing called deep learning. Now, deep learning is very interesting because it requires a ton of computational power, which we didn't have 20 years ago. So how deep learning actually works, and this is the easy example of face recognition, is I have my pile of input data. You see down here is let's say 1 million different images of all the people here in the room and their families and so on and so on. And on the other side, I have labels, which is your names, right? And then I feed that into my deep neural network, and the word deep quite literally means it's just a deep network. It has many, many different layers, and in these different layers, what the network does, it starts abstracting features, right? So here you see kind of edges, and here you see things like prototype noses, prototype eyes, and other features that a face typically has. And then further down the line, you see what we call prototype faces. These are typical, kinds of faces that you would see. And even further down the line, you would start seeing. You would then pull all this input and say, okay, this image is actually this person's face with 95% accuracy, and so on and so on. And that's how it kind of works. So there's no magic. There's nothing like no tiny little person in your computer who then says, this is the kind of stuff that's happening. It's basically statistics on steroids, as I like to say. What that kind of entails, and sort of the perspective of that is, that needs a lot of computation power. Again, one of the big computation power providers in this world is the stock price of NVIDIA from this morning. Obviously skyrockets since 2014 when this technology started to being adapted. Now, people will say, blockchain, Bitcoin mining and stuff like that. Obviously, that also feeds into that, but that's a strong signal kind of that I like to use here. Now, don't fall from your test. That's the only formula I'm going to use in this presentation. But the whole point I want to get across here is there's no magic, there's nothing special. It's basically simple math. So what you'll see in a minute is one of the instances of a computer learning how to play a game. And the math behind that, or the kind of computer programs that people build to do that, are built on a very simple heuristics. And I'm not going to explain the details of this, but you say Q is a state. That's like a state I'm in. So say I'm giving a presentation and I'm thirsty. So that's a state I'm in. So then in every state, I have actions that I can take. So I could drink some water or not drink some water, right? And then you would compute the desirability of that action in that state by basically just predicting the future state I'm going to be in. So if I drink water, I'm not going to be thirsty anymore. That's good. I have a high reward function. If I don't drink, I'm still going to be thirsty. That's not good. I have a low reward function. And then you do that over and over and over again and build like a prediction view for the future, and then I basically just start picking my actions based on maximizing my future reward. Now, if you do that in this beautiful game of Breakout that probably most of you have played at some time in your lives, and you do that repeatedly and repeatedly for like 10 minutes, that's kind of how I would play the game, which is like not super great. And all the input you give to that machine, I just want to be really clear here, it has the possibility to move the cursor just like we do, and it knows that's the only pre-programmed thing. It knows the score is up there and you have to maximize that score. So instead of me saying thirsty is bad, they just say, okay, high score is good. That's like the reward function they give to that. And then you play over and over again for like 60 minutes, and then it's already like basically the level my brother would play at, and he's like a super good computer gamer, so that's already super impressive. And then you continue playing with that game. No other input required, nothing at all. And that's trained on my MacBook, which is like a typical MacBook. After 4 hours of training, you see people say magic happening, right? So obviously because the computer learns the best states that the game should be in, and again, there's no magic, it's just knowing the value of each state. You say, okay, the best thing that could happen to me is if the ball basically plays itself and the score skyrockets. So that's what then happens, and people, in media went crazy, and that's like 3 years ago, 4 years ago now. So that's what we can do now. Google DeepMind, open source this beautiful joint venture project with, I forgot the company who built StarCraft, but StarCraft 2 is going to be an open source machine learning training environment. So instead of playing Atari, I can now have my own agents that I built playing StarCraft, which basically makes this AI's kindergarten, right? So that's kind of interesting to see, and I'm sure many is going to pick up on it later. If that's where we train our systems in these confined space environments where most of the rules are not really the rules that we typically see in real life, then that's the kind of AI output we're going to get. And I want to remind you that AI is only going to do the things we make it observe that are the right things to do. So it all depends on the data you feed into that stuff. Now, they told me that I have to talk about the bright side of AI. I typically like to, point out challenges, because usually I talk in front of audiences where everyone is like super excited, and AI machine learning, we've just published a paper that we can do this 3% better than everyone else. So like the academic feedback. But here you can see AI has very strong applications already, and that's CB Insight, most of you probably know this, where the money actually goes to in terms of investments for AI companies. So healthcare is obviously huge, and I'm sure Bart is going to talk about that tomorrow in more detail, what AI and machine learning can enable in healthcare. And then obviously the things like e-commerce, marketing, IoT, and kind of all these big data analytics topics. So there's a lot of investment going in, and we see a lot of very interesting companies coming out. Mostly, again, healthcare space. Cybersecurity is also super interesting, where we can now start, instead of having penetration testers have to do penetration testing, we can now basically build a reinforcement learning algorithm that instead of playing a game, it plays the game of hacking your company and tries to basically do that. And so on, so on. We see many more interesting things. But honestly, I want to give you a quick hint of sort of the things we can do, things we can't do, and some of the challenges we see in machine learning today. Remember this big chunk of linear algebra of basically you have features and you take those features and then you put labels on them. Now, if you do that with Google InceptionNet, which is, well, at least last year it was, today no one really knows, but last year it was the best well-trained machine learning algorithm for image recognition that was out there, freely available to everyone. If you do that and showed an image of Tiger Woods, that thing would say, okay, cool, 95% sure that's Tiger Woods. That's already super cool, and that's what the news will talk about, is like, oh, they're better at recognizing people than humans are, because obviously I wouldn't be able to recognize Tiger Woods. But then the interesting thing here is it's also 4% a golf ball. It's like, how the F is this a golf ball? It's like every human, like babies, will be able to tell you, oh, it's a human. I don't know which human, but it's a human. And most likely, yeah, it's like a golf player because he has the shots and stuff like that. But because Tiger Woods almost always appears in images where there's also golf balls, and if you remember the kind of learning process, AI learns by having correlations between the pixels on the image and the output label. So obviously, if almost every image that Tiger Woods is in, there's also a golf ball in, the system will think that whatever is in the image is a golf ball. Equally, if you show this thing a golf ball and you only train it on images of Tiger Woods playing golf and not like other people, then it will think the golf ball is Tiger Woods. Which is totally absurd if we think about, how humans would. I'm not going to comment on Angelina Jolie. You can think about that yourself. Now, if you extract that a little further and you think about scene description, movie titles, and this kind of stuff, you see some of the things that they will talk about in the news, and you know that TechCrunch and Wired will always publish and say, AI, next big AI breakthrough, AI can now label images. So you're like, great, that's a person riding a motorcycle, and that's a group of young people playing the Frisbee. But then if you actually look into the research, and I'm doing that myself, right, so the examples that they will never publish in the news is stuff like, I'm probably doing this here. A dog is jumping to catch a Frisbee, and there's like a girl hugging a dog, which is obviously totally wrong. There's a refrigerator filled with lots of food and drinks, and it's basically a traffic sign with like stickers on it, which is totally wrong. But these are the kinds of things that I will typically not talk about in the news. Now, obviously, that's a little bit of an older image. So today, obviously the field is advancing, but that's the kind of mistakes the systems make. So we're not there yet, and when we think about intelligence and how a human would typically define intelligence, it's not only about perception, it's also about common sense, planning, analogy making, reasoning, language, and so on and so on. What AI is really good at today is deep learning. Deep learning at least is really good at, that's perception. Everything else, there's like less investment in today because deep learning is so cool, and we're not really quite there yet with. So the key challenges we have in machine learning today is this thing called common sense, right? It's like being able to say that's obviously not a golf ball. It's a human, I don't know which human, but it's not a golf ball. We can't really do this. Explainability, again, that's a kind of a black box system. We don't really know what's going on in this huge linear algebra pile that we just mashed together. We have no clue how to make sure that these systems make really ethical decisions. And because again, if you think about how it works, it will always copy our input, right? It will learn from the data we give it, and there's this beautiful project by a good friend of mine, Mo. He was previously chief business officer at Google X, and now he says, dude, if we want to build like huge AI machine learning algorithms, we have to make sure that the data it gets, meaning the observations, are positive and they're an image of what we want to be as humans, and not 85% porn and the rest is like news about wars and images of people killing each other, and mostly white educated males when you talk about humans, and all this kind of screw that we have in the data set of the internet today. He says, okay, we have to make people happy and make sure that we portray people being happy and doing good things, because that's what AI will then pick up to do. Generalization, obviously a big issue, right? We've seen that it's kind of like end-to-end mapping. We can't really do general thinking today. And then data privacy, one of the things I'm personally very passionate about is the idea of how do I make this thing train without getting all your data on my computer, which obviously you don't want to do in most cases, especially when you talk about healthcare, etc. But how can I still give you all the benefit of each other's data and each other's input and my expertise in building these systems without ever having to see your data on my computer? So that's the kind of things. Common sense, very quick. Solution, people say, oh, we built this, the Allen Institute, Allen, the co-founder of Microsoft, that people less talk about. I think he's much more interesting than the other one. Say, okay, we get all this like image analysis, text analysis, data set, put it in Alexandria, right? See the analogy. That builds a common sense repository, and it will then help us do this. And the key output of this thing is being able to answer a question like, which of these will fit through the door? We can't do this today with AI and machine learning, right? And they spent $125 million on doing that. And they don't know if they're going to make it, right? That's kind of where we are today. Explainability, that's a research paper we recently published about an approach on how could you theoretically help understand the decision-making process. So you basically look at feature detection, and you say, okay, here's a vase filled with flowers sitting on the top of a table, and the vase is everything that's blue, the flowers everything that's red, the table is everything that's green. That's kind of an interesting approach. So we at least know the system builds the description because of these things in the image, and they're located here, but we still don't really understand, how it works in detail. But very interesting work happening. Ethical decision making. Again, we take humans as a labeled data set, and we say there's this project, MIT Moral Machine from the Media Lab. They say, okay, who's better in ethics than humans? So we're just going to have a bunch of humans label data sets for us. So they show you questions like, what should the self-driving car do? Drive through against the wall and basically kill itself, or kill these humans by taking the other way. And that's a very difficult question for humans to answer, but more so difficult for an AI machine learning tool to answer. And they basically say, okay, we're just going to see what humans do, and then just make the machine do the same. There's this very interesting question about human and machine, and I posted on Monday or so this week, I posted on Facebook, Google Duplex AI system accomplished real-world tasks over the phone, and so on and so on. And one of the faculty members actually from Future.io, a guy who works at GM, I think, says, for ethical reasons, the digital agent should always begin a conversation with the declaration that it's a machine. Now, kind of if you talk about, gender equality is the same discussion, but if you talk about fairness and such things, I just wanted to provocate. That's not my real opinion. I think he's totally right, but I just wanted to provocate. So I said, don't agree. Call center agents should then declare they're a human call center or what? And he's like, okay, we have to talk about that. And when Google then decided, just one day later after they made this announcement, they decided, okay, we're going to have our AI start that conversation with, hi, I'm Google Duplex, I'm an automated voice agent, and I would like to make a restaurant reservation, basically. So that's kind of what's happening. But you see the dissonance here with this whole idea of AI agents taking over, but so taking over is like the worst way to frame it, but helping us with more and more things in our day-to-day lives. And then as they become more human and at least imitating human beings, it becomes a real challenge to see, okay, what do we give them, what do we don't give them, where do we use them, and how do we use them? So I just want to give this as a food for thought for you guys to think about if you're going to apply AI and machine learning in your businesses. How do you deal with these kinds of dissonances? Generalization. There's a very interesting some work that's being done on sort of learning what a face looks like, and then they say, okay, if you need a makeover, we can do it for you. And you take all the images that an AI would do, label as smiling woman, you basically average all these images. You get the prototypical smiling woman, you take neutral woman, a neutral man, and then you can do math with faces, which is kind of cool. And you can generate, this system has never seen smiling man before. It only saw neutral man, smiling woman, and neutral woman, and it can generate faces, which arguably don't look that real, but you get the idea. They generate smiling face man. So there's a tool that can now understand what the concept of smiling means and what the concept of man and woman mean, and do logic with it, which previously, again, we would say only humans can do that. A labeled computer would never be able to do such a thing, and now here you go. Data privacy, I think. So now, just next week, I think, if any one of you knows about like all the regulators come to all the AI startups and they say GDPR, and everyone's like, oh shit, what the fuck are we gonna do with this? And they're like, we can't. No. I make a comment about GDPR. Never against people. So they basically say you have to now give all the control about data back to the users. And obviously for AI and machine learning company, that's like the worst thing that could happen, because I monetize on all your data. I monetize on being able to say, oh, my typical observation of what a person like you would buy is this, because I have everyone's data. Now if I have to give that or all people the right to delete their data, the right to move away with their data, and all these kind of things, that's a serious threat to my business model. But now, we have to, that's like a very good, a triggering point to actually start a conversation about data privacy and start thinking about how you can build concepts such like federated learning, and I'm going to spare you the details of this, but concepts like this where you can benefit from everyone's data without having to pool it together, and then distributing a hive mind model that learn from everyone send it back to you, and you can then benefit from your neighbor's data without ever having to see, or without me ever having to see their data, but building very good services on top of that. So these are the challenges. Again, there's obviously more than that, and there's obviously more solutions than what I was able to show you today. But I think for every single threat that AI and machine learning has posed on it today, I think we have already some solutions, and that's kind of the bright side of it, right? We have some solutions, we have some ideas at least. Some of them might work, some of them obviously won't work, but we can start having a conversation about the things that we can do today with the systems we have, obviously keeping humans in the loop. I think I like to talk about this term of augmented intelligence rather than artificial intelligence, where you start having, instead of self-driving cars, you have an AI that monitors your attention when you're driving the car and takes over when you distracted with your phone or whatever, but then forces you to go back and actually drive the car yourself, which obviously is a big case. And there was this beautiful article, I had to do this, about would you trust an AI doctor? I think the question we should rather ask, and that's a big fuck up here, we should rather ask, would you trust your doctor double-checked by an AI? Instead of, I'm kidding, and sorry, I'm going to skip over this for time's reason. People talk about decentralized machine learning. That's like the big thing today, where they say, okay, we have to give data back into the hands of users and do all this kind of stuff. And people waste $32 million in 30 seconds with a concept on blockchain that says, okay, we can train on the blockchain AI and machine learning algorithms without having to centralize the data. So there's huge demand for such things. That means that we're moving in the right direction. But basically, what I want to leave you with is the best way to predict the future is kind of to actually build it, and I bet many people say that it gets attributed to Abraham Lincoln, and always just carry a towel with you in case you're panicked. Thank you.
Just quickly, you mentioned GDPR, and you actually alluded to something I call the privacy conundrum, which is we feel we want privacy, but how will that impact our ability to apply these technologies and be competitive in the global marketplace? How is a company, you're at Telefonica, how is a company like, and I don't mean the regulatory team, the compliance team, but I mean the technology and operations and customer service, et cetera, how is the company digesting something like GDPR and thinking about what to do and how to do it? And then what effect does that have on you as part of the technology team?
Yeah, so I think the right answer, obviously, is you take a proactive approach and you say, okay, we anticipate this, and we've already, to all our users, sent out consent forms and make sure that all the data we currently work with and own we're able to do, and obviously you have a churn rate in that. So some people obviously say, I don't want that, and then you have to delete it. That's regulation today. I think what the more interesting part from the technology perspective, obviously, is, again, making sure that you build frameworks that can work in that environment, like federated learning, like tools that will help you not have to take ownership on everyone's data, but rather keep it on their phones, keep it on their laptops, keep it on their whatever, and make it useful in that perspective. So I think it's always a proactive approach and finding technology solutions to problems. Right? We've gone around this with internet, we've gone around this with cookies, for example. Like there's many ways in which regulation, took a big hit on the tech industry, and we always found ways to deal with it. So.
Yeah. So to summarize, maybe you're saying create applications and opportunities that people desire. They'll be more likely to opt in as a result. Is that what you're suggesting?
That's one part of it, and then the second part of it is because that's kind of hacking your way around it, right? Is you just say, okay, there's this regulation, but I'm just going to make sure all my users still give me consent, and I still own all their data, and I'm still going to, sell advertisements with it or whatever. I think the second or next level on top of that basically should be, okay, now that I have a service that people desire and people want, how can I make sure that their data is always protected and their data stays in their ownership, but I can still deliver the service? It shouldn't be a question of, I need to get all your data to deliver that service. The question should be, do you want it or not? Let's not talk about how to.
Great.
Yeah.
Well, thank you. We'll hear more from you in a bit when you join many up here.
Awesome.
Great. Thanks.